EssProM EPM Simplified, Oracle EPM Forecasting Walkthrough. Introduction. In this demo, I will walk you through the complete forecast process within the application, starting from setting up the forecast scenario and version, configuring the global variables, building the forecast through scenario copy, and finally reviewing and adjusting the forecast reports. Step 1. Navigating to scenario and version. To begin the forecasting process, the first step is to navigate to the scenario and version dimension. These are two of the core dimensions in the application that control how forecast data is organized. Under the forecast scenario, you will notice several versions maintained, for example, 6+6, 7+5, and so on. The version dimension allows us to maintain multiple versions of the forecast, depending on the forecasting cycle and the number of actual months available at the time of forecasting. For instance, the finance team may create a 6+6 forecast version, where 6 months of actual results are combined with 6 months of planning and budgeting data to arrive at a full-year outlook. The remaining 6 months of forecast can then be adjusted as needed to finalize the forecast report. Step 2. Configuring global variables. Once the appropriate forecast scenario and version have been created, as you can see, a forecast scenario already exists in the system. The next step is to configure the global variables, also referred to as substitution variables. This step is typically performed by the administrator, since only admins have access to modify these global placeholders, which impact all planning and budgeting users across the application. These variables are used to define key parameters for the forecast, such as Act Months, defines the actual months considered in the current forecast process. For example, in a 6+6 forecast, the actual months would be January through June, the first 6 months of the fiscal year. Forecast Current Version identifies the version of forecast currently being worked on, such as the 6+6 forecast. Forecast Months defines the remaining months to be forecasted, such as July through December. Forecast Scenario defines the scenario associated with the forecast. These and other forecast parameters can be altered based on the specific requirements of the user or the organization. Step 3. Building the forecast through scenario copy. Once the global variables, along with the actual and forecast months, have been defined, we proceed to building the forecast. This is done by bringing the actuals into the current forecast version and using the budget as the starting point for the remaining forecast months. This is achieved through the utility section, which allows planners to copy data from one scenario into another. For example, there is a finance scenario copy for all finance-related information and a sales scenario copy for all sales-related information. Within this section, we select the From Scenario, From Version, and the destination, in this case, the forecast scenario and forecast version where the data will be copied. This means 6 months of actual data will be copied in, and the remainder will represent the forecast. The process begins with the Scenario Copy Finance option. Once selected, the system prompts the user to enter certain parameters. From Scenario, the scenario from which the data will be copied. We begin by copying the budget data into the forecast and later override the actual months by performing a separate data copy of actuals into the forecast. From Version, for example, if the user is currently working on the base version of the budget, the data can be copied from there into the appropriate forecast version, such as 6+6. After selecting the correct source and target scenario and version, we click Launch. This triggers a backend script that copies the entire scenario's data, for example, from budget FY26 into the 6+6 forecast, FY26. Once the scenario copy is executed successfully, a confirmation pop-up message will appear, and you will be able to see the copied data reflected side by side in the application. The next step is to override the actual months by performing a data copy of actuals into the forecast scenario using the Data Copy Actual to Current Forecast Scenario option. This copies the actual month's data, in our case, the first 6 months, January through June, from the actual scenario into the forecast scenario. Step 4. Reviewing forecast reports. Once the scenario copy has been completed, we return to the home screen, where you will notice the same navigation structure available for the budget, such as financial statements, and other planning modules is now also available for the forecast, tailored to the client's requirements. Since the actual months and budget data have already been copied from the budget scenario, this information is now reflected under the financial statements for the forecast module. Several reports are available, one of which is the TNL monthly report. This report presents a 6+6 forecast, where the version can be selected from the top of the screen depending on which forecast cycle you would like to review. For example, other forecasting cycles such as a 4+8 scenario, where 4 months are actual and 8 months are forecast, can also be reviewed. Within the report, the months highlighted represent the actual months, while the year total column displays the full forecast, combining actual and forecast months. A variance column is also available, showing the variance between the budget and the forecast, allowing users to compare the two scenarios after the forecast has been prepared. Step 5. Adjusting forecast data. At this stage, the data reflects a direct copy from actuals and budget into the forecast. However, if the finance team or planning users wish to adjust the forecast, they can do so from the home page under the forecast section. For example, if a user wants to update the revenue figures, they can select the relevant planning module, such as revenue, and update the forecasting figures as needed. Since this data originates from the budget, it reflects the global assumptions carried over from the budget into the forecast. As an example, we can adjust the available inventory for sale, which is currently calculated as total inventory minus actual sales as of the current month. If we update the number of units, for instance, setting it to 10, and click Save, the same calculation logic used in the budgeting module is applied to the forecast, since no changes are required to the underlying forecast logic. Once saved, the updated numbers will immediately reflect in the forecast without impacting the current budget figures. To confirm this, if we navigate to the full budget model, we can see that it remains unchanged. Any updates made in the forecast do not affect the budget, since the budget is already finalized. Similarly, users can adjust other forecast parameters, such as elevating prices for higher sales forecasts, or updating any anticipated sales cancellations. And the system will immediately reflect these updates in the remaining forecast, again without impacting the budget. Conclusion. To summarize, the sales figure was approximately 501 million, combining actual and forecast data. After making adjustments in the forecast sales module, we can see the corresponding update reflected in the final forecast year total. This demonstrates how the system enables the finance team to maintain an up-to-date and reliable view of the financial outlook, supporting informed decision-making throughout the year. Once the completed forecast has been reviewed and validated, the required reports can be generated to provide management with a clear view of actual performance, budget, and the latest forecast, along with the variances presented, as we have seen in today's demonstration. Thank you for your time today.